Good morning, Year 4. It's Wednesday, the 3rd of February, and today we're going to do some more work on reading line graphs. Okay, let's have a look at our in focus task today. It says a glass of water was left in a freezer. Its temperature was taken every 10 minutes. This is the start of the experiment here, and this is the end, and you can see every 10 minutes. Now it's quite difficult to read the thermometer here, the red thermometer, but if we turn that information into a table, it's much more easy for you to see what happened in that experiment. So we've got the time here. Oops, going across there, children, going up in 10 minutes. And we've got the temperature shown in degrees Celsius here. Okay. Now, first thing that you've been asked to do, or we're going to do together, is to draw a line graph to show how the temperature of the glass of water changes over time. And if you remember last time, I talked to you about line graphs being really good to show something changing over time. So this line graph has been drawn. Now we'll have to have a look first of all at our scale. Remember the scale? It's going up the side here, and you can see the scale is going up in degrees of 5 degrees each time. 5, 10, 15, 20, 25, 30. And along the bottom of our graph, we've got the time in minutes to show how that is changing. Okay, so at the beginning of the experiment, when no time was gone, no time had been taken, we can see that the temperature was 25 degrees. And there it is at the top there in the chart as well. Okay. Now our question is, did the temperature increase or decrease or remain the same? Well, let's look at our line. And this is where the line graph comes in again really handy. Our line starts here at 25, and you can see it decreases after some time all the way to here. Yeah, so it is going down, isn't it? And you can see after 40 minutes, can you see there, it's actually hit 0, which is freezing point, isn't it? It's actually hit 0. But can you see how even after 50 minutes it's still shown there in red on the graph? It's still showing us that the temperature is at 0 degrees, and we can see that in the table at the top as well. Can you see 40 minutes at 0, 50 minutes at 0, 60 minutes it's 0 degrees, but we still show that on the 0 line on the graph, but it's definitely decreased, hasn't it? It's come down, the temperature. Okay, so let's have a few questions about this graph. What was the temperature of the water in the glass at the start of the experiment? Okay, so when we started the experiment, there was no time gone, so it's right here. And you can see at the start, yep, you're absolutely right, it's there, isn't it? So that was 25 degrees Celsius. Okay, question 2, a bit harder. You're going to get some questions a bit like this today. By how much did the temperature drop after 20 minutes? Okay, so we've got here, it starts at 25 degrees, yeah? And after 20 minutes, so 20 minutes into the experiment, it's there, isn't it? Which is 5 degrees. So it's dropped from 25 to 5. What sort of calculation are you going to have to do? Can you think? Yep, you are going to have to think about doing a subtraction, and the difference between those is 20, isn't it? So remember, watch again, you've got 25 here. Whoops, sorry children, that's me. 25 here, and it's dropped to 5 after 20 minutes to there. So it's 25, subtract the 5, or the difference between those two would be 20 degrees. By how much did the temperature drop in the next 20 minutes? So the next 20 minutes is going to be, oh, my mouse is going crazy today. It's going to be from here, because that was the first 20 minutes. So for the next 20 minutes will be from 20 minutes to 40. From here to here. How much did it drop? Well, at 20, it was 5. And by after 40 minutes, it's down to 0, isn't it? How much has it dropped? 5 degrees. It's gone from 5 degrees to 0. So it's dropped by 5 degrees. What do you notice about the temperature after 40 minutes? Here's 40 minutes. I did talk briefly just before about it. Can you see at 40 minutes? We're still marking it at 50 and 60. It's in this red here. What do you notice? Well, it stays the same, doesn't it? It has reached that 0 degrees in the freezer and it has stayed the same. Oh, just lift that off there a little bit. There you go. The temperature reaches 0 degrees and ceases to fall. It stops going any lower. Okay, now, one of the things you have to be able to do, and you can do with a line graph, is compare data. I've got 2 graphs here for you. This line graph here, this line graph shows the amount of rainfall from July to December in part of Singapore. Okay, and this line graph over here is rainfall in the same period of time but in London. Now, what do you notice if we were to make some comparisons? Because the little boy is saying compare the 2 line graphs. Why is this difficult? Have a little look. Why is this going to be difficult for us to do? Because if I look at a distance from these 2, it looks from a distance that this line is taller. It's further up the graph. I think this one looks as if it's got more rain because it's higher up. But I need to look a bit closer. What am I missing? Who spotted it? You are right. Those of you keen eyes at home, this is in centimetres in this one, and this one is in millimetres. So we haven't got the same scale, and that's difficult to make a comparison when we haven't got the same scale. Okay, so for example, here, yeah, if I'm at 60, here, 60 millimetres is the same as how many centimetres? We've done a little bit of this in school already. It's only 6 centimetres, isn't it? 60 millimetres is 6 centimetres, okay? So if I was to show it on here, that 6 centimetres would be right down here, okay? So at the moment, these 2 graphs are very difficult to compare. When we compare, it is easy to see when the scale is the same and the data is on the same graph. So at the moment, we've got two different scales and we've got 2 different graphs. We need this on the same graph. And this is why line graphs are so good. Here it is. So I've got 2 lines now. I've got this blue line showing Singapore rainfall. And I've got this one here showing London rainfall, okay? And you can see straight away if I was to ask you questions about which had the most, which had the least, which had the biggest increase. You can see this line is going up steeply. That means it's going to increase much more than the rainfall in London. But I've now got that data on one graph. And so I can think about and make comparisons much more easily. Okay, so over the next 2 days, you are going to be doing quite a lot of graph work. You're going to be answering questions on line graphs, and you are also going to be making these comparisons between 2 lots of data. As well as that, children, don't forget your 15 minutes of TT each day and upload your work onto Teams, or you can email me at year4@southstanleyjuniorschool.co.uk. Okay, thanks children. See you soon.